Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on the 26th of June 2025, T 1 hour 58 minutes and 9 seconds, .000Z. This paper, out just 2 days ago, introduces a new animation framework that scored a 4.8 out of 5 for realism in user studies. It's titled PhysRig, Differentiable Physics-Based Skinning and Rigging Framework for Realistic Articulated Object Modeling, and it aims to fix those unnatural candy wrapper effects we often see in animations. The authors move beyond traditional methods by simulating characters as soft body structures, driven by an internal skeleton, which results in much more physically plausible movement. Alright, so this figure gives us a great overview of how their framework, called PhysRig, actually works. It starts with a 3D object, like the character, or the T-Rex you see here. The system first computes what are called core skinning weights, which are basically initial guesses for how different parts of the skin should move with the skeleton. These weights then help initialize embedded driving points, which control local deformation. Everything is then fed into a physics-based simulation that uses material parameters, like stiffness, to generate a final, natural-looking animation over time. Okay, moving to the results, this table shows how PhysRig compares to traditional methods. It's up against several baselines using linear blend skinning, which is a common but older animation technique. Performance is measured by two things: user study rate, a realism score, where higher is better, and chamfer distance, a geometric error metric where lower is better. Across all characters, from humanoids to a T-Rex, PhysRig consistently achieves the highest realism scores and the lowest error. The final average column really drives this point home, showing a clear performance advantage. This table then digs deeper with what's called an ablation study, which is where you test which parts of your system are most important. The authors compare their key idea of using material prototypes, a small, learnable set of material types, against other methods. The results are clear. Their prototype approach gets much better scores. It also shows that properly initializing the driving points, which are key spots that guide the deformation, drastically speeds up how fast the model learns, cutting the required convergence iterations from 8,000 down to just 2,500. It's a very efficient design. Building on those component tests, this figure gives us a great qualitative comparison. On the left of each pair is their PhysRig result, and on the right is a traditional skinning method. You can really see the difference. The older method suffers from that classic candy wrapper effect, where joints twist and the body collapses, losing volume, especially on the leopard and T-Rex. In contrast, the PhysRig animations maintain their physical presence. This is possible because their entire framework is differentiable, meaning it can be optimized with modern learning techniques to achieve this realism. So to wrap things up, PhysRig really bridges the gap between classic animation and modern physics-based machine learning. By simulating characters as soft bodies, it finally solves those unnatural joint collapsing artifacts. The key innovation is using a small set of learnable material prototypes, which are like templates for stiffness, to make the optimization fast and effective. This differentiable approach creates much more realistic movement. Well, that's all for today. Thanks for tuning in to the AI Research Roundup. I'm Alex, and I'll see you next time.